next thing that I want to look at is I want to solve a few problems. Find the indefinite integral of negative 4x cubed. So I'll use the symbols that I've just talked about a few minutes ago. So the integral of negative 4x cubed with respect to x will be equal to, now the first thing you need to do is you can use the formula that we derived in a few minutes ago. We saw from the reverse process of differentiation. So that will be negative 4x to the power 3 plus 1 over 3 plus 1 plus c, which will give us, that will be negative 4x to the power 4 over 4 plus c. Simplify that, which will be negative x to the power 4 plus c. Okay, b, the integral of negative 5 over x to the power 7 with respect to x. Now, first thing is you can always pull out these constants. You can pull them outside the bracket to end up with the negative 5 integral of 1 over, and 1 over x to the power 7 can be written as a negative in this. So, okay, and then you finish this off by integrating it, of course. So you'll end up with negative 5 x to the power negative 7 plus 1 over negative 7 plus 1 plus c, which will be so negative 5 x to the power negative 6 over negative 6 plus c. Finish that off. So we'll end up with 5 over 6x to the power 6 plus c. Okay, let's continue with number 2. So integral of x to the power of 2 over 3, and we're integrating with respect to x. This will be equal to x to the power 2 over 3 plus 1 over 2 over 3 plus 1 plus c, which will give us x to the power of 5 over 3 over 5 over 3 plus c. And you can finish this off by rewriting this denominator to 3 over 5 x to the power 5 over 3 plus c. Okay, number 3. You can integrate this function term by term. So let me first of all rewrite it. So x to the power a quarter, and we integrating with respect to x. So the integral of 1 is just x. This is, I'll explain why. You have 1x to the power 0, and then you add 1 over 0 plus 1 minus x to the power a quarter plus 1 over a quarter plus 1 plus c. Simplify this. So this will just be x minus, then here you have x to the power 5 over 4 over 5 over 4 plus c. Now if you simplify that, you'll end up with x minus 4 over 5 x to the power 5 over 4 plus c. Okay. And now I want to look at some rules for integration. Some of these rules are actually in your formula booklet. Now, Suppose here we have the function, and on the right we have the integral. Now, any constant k, I just organized this, I think, in a table, something like a table. So any constant k, if you integrate it, you'll end up with kx plus c. Suppose you're integrating with respect to x, you'll end up with that. If you have e to power x, you just end up with e to power x plus c. If you have x to power n, we've already looked at this, we'll end up with x to power n plus 1 over n plus 1 plus c. If you have um, a function like 1 over x, you'll end up with ln of absolute value of x plus c. If you have cos x, all these are in your formula booklet. So sin x plus c. If you have sin x, you'll end up with negative cos x plus c. Now, if you have second, now this is not in your formula booklet, the last one, but I'll show you how you can figure it out from your formula booklet. They do give you the derivative of tan x to be second over x squared. So all you need to do is you can use derivatives to know the antiderivatives. Anyway, you'll end up with here with tan x plus c. So these are important integrals. They are in your formula booklet. So if you look in your formula booklet, standard integrals, most of them are here, okay, except the one for second, which you can find it by looking at derivatives. So you know that derivative of where is it? Okay, here. You know that derivative of tan x is second of x squared here. So you can use the reverse process to find the antiderivative of second of x squared, which is here.